All right, folks, welcome back. CIS Module 5, CIS Module 9. We are going back now to do database and access stuff. If you do not have Microsoft Access software available, this week is where that becomes a problem for you. So please let me know if you need that, and let's get into it. So, talking about databases generally today, and then we'll get a little bit hands-on as we move. So, first thing is, what is a database? So, think about we were working in Excel, and we started to have pretty decent collections of data, right? So in Excel, you have your rows and your columns, and then you have your individual sheets. That works if it's a pretty small amount of data, but what if you're talking about instead of 50 rows, you're talking about 50,000 rows? It's going to take you a long time to scroll all the way through Excel and find out where you want to be. So when you get to that next level of complexity or next level of having so many things, then you want to start looking at a database. Textbook wise, what is a database? It is a collection of related data. So you have to store and define your data, right? So obviously it's a place to store it, and then the definition, make sure it's easy to work with once you have it stored. Once you do that, you can sort it, you can organize, maybe categorize, put some filters on it. You can do something called querying, which is a way to pull out or query, find specific data. And then you have your big collection, but maybe you only need a small amount of it for what you're doing. So when you do your query, when you ask the database to give you something, you can take it and output that as a report, as an Excel sheet. You can automatically email. So it's really powerful, all the things you can do. So why would you want to use a database? One, better management. Just think about in that Excel scenario, when you have a lot of information, a lot of data, it's going to be pretty hard to handle it in Excel. So you want to move to something it's made for that. Reduce your data redundancy. What that means is if you're storing the same type of data in 3 or 4 different places, in a database, you don't need to do that. You only need to store it once, and then you can use some of the features of the database to use it in the different ways you need to use it. And the big one is to reduce data inconsistency. So think about when you are typing things in or maybe using paper forms, there is a lot of opportunity for user error, right? So maybe the data is not complete. You ask somebody to put their birthday and they just say July 5th. They don't give you the year. A database can enforce that, where if they don't put the year, it's going to throw an error message and say, in order to move to the next step, you need to give me your full birthday. And then the same thing for inappropriate data here doesn't mean, like when we're all yelling at our 6-year-olds. Inappropriate data here means that it's not the right type, where you ask maybe for a salary number and they say none. Well, no, I want a number, right? So the data, when you're working with data consistency, it's going to enforce that it is a number put in when you're asking for a salary number. A little bit deeper, There are different types of databases. What I was describing there and what we're going to be working with in this class is a relational database. What that means is that all of the different parts of data, all of the tables are related to each other. So that data is very structured, right? It's clearly defined what goes where and how you do it. You have this concept of relationships are one to many, one to one, and many to many. We'll talk more about what each of those are. And then we have an entirely different concept of a non-relational database. These are the big data things you hear about. This is unstructured data, right? So you're not talking about tables and rows. You're talking about music clips or videos or pictures, big documents, anything that can't be broken down into very neat categories, but you still need a way to store it. A non-relational database is what you do for that. All right, so thinking now about how do you actually, in a relational database, right? How do you store and define that data? First thing that you need is metadata. And this is data about the data. So that's going to tell you what type is it? Is it a number? Is it a word? Is it a date? The properties, the size, what do you want to do with it? Is there a default value and maybe a caption or description? We have these things called the primary key and foreign key. When I say referential integrity, think about we have all of these different tables and they relate to each other. The keys are how you do that. Don't worry, we're going to talk through exactly how that works. And then in order to get the data into your database, a great way to do that is with input forms, right? So think about when you are going to a new doctor and you try to go in for the first time. They don't just ask you, hey, tell me all the health stuff we need to know about you. They give you a form, and that form has exactly what they need, right? It says put your name here, put your phone number here, put your insurance information. Have you had this condition, that condition, right? That form guides you through exactly what they're looking for. That's a very good thing to do with a database as well, because when you have somebody use a form, you can do data validation on that form, right? So the range check is if you're asking somebody how old they are, right, for their age. If somebody tries to enter 775, you know that's not right. So maybe you could set the age range to only accept numbers from 0 to 150. Or a completeness check. Is this a required field, right? That's the birthday example we talked about. Consistency check. Does this match up with everything? And then just a very simple one is, alphabetic or numeric, right? Is it a number when it's supposed to be a number? Is it letters when it's supposed to be letters? Or you can even get more complex. When you're asking for an email address, let's think about what goes into an email address, right? It's always going to have the whatever name that person has, and then the @ sign, and then at something.com or .org or .net, wherever you may have. So you can set up your data validation to check that an email address follows that pattern. Or I have even set it up when I'm doing stuff here at the college and I want you to use your student email, I can set that data validation up to only accept your @maricopa.edu email. If you try to give me if you try to give me @gmail.com or @outlook, it's not going to accept it. The data validation will only accept @maricopa.edu. All right, I like cartoons. So let's take a minute and read this one. I want to give you a minute to go through it yourself, and then we will talk about it. All right, so what we have going on here is something called SQL injection. I'm getting way off into left field here, but this is the kind of stuff that makes me laugh and makes me happy, so I'm sharing it with you. So what's going on here is in this 1, 2, 3, in this third slide, where it says, did you really name your son Robert, this weird looking stuff, drop table students? Now we're going to talk about queries in a minute. In structured query language, when you say drop table students, that's going to completely wipe out the entire student registry, right? So the joke here is when you're having a form, and if you don't have input validation on that form, somebody, if they know what they're doing, can purposely put a bad input, and if you let that go to your database, you can lose all kinds of things, right? So they say, well, we lost all the records, I hope you're happy. And she says, well, I hope you learn to sanitize your inputs, right? Or validate your inputs. Yay, funny cartoons. All right, so thinking about queries, all a query is a very powerful filter. You can query a single table, or you can query multiple tables. And the best part is you can save that query for later. So that way, if you want to come back and look for similar or the same data, you don't have to do the work again. You just use that query that you already used. We'll get hands-on with this, but thinking about maybe you work in a help desk and you want to be able to query all of the tickets that have been open for more than 30 days. If you write that query one time, anytime you want to find out the tickets older than 30 days, you just use that same query and it will bring it all what you're looking for pretty much instantly. So when we're talking programmatically there, you're going to be using structured query language or SQL. Actually, it's a lot simpler than you think it is. It's a very English-like language, and it uses relational algebra, right? So equals, greater, less than, not equals, those sorts of things. And so I said you can use one table or you can use multiple tables. If you're using just one table, we call that a select query because you are selecting the data that you want from one table. And if you use multiple tables, we call that a join query because you're joining two tables together to get the information that you're after. All right, terminology bingo. I know I kind of glossed over these before, so let's take a minute and think about them. So data is your raw facts. They don't really have any meaning. That's just the numbers that you're putting into a computer. it becomes information once you do a little bit of processing on it and it makes more sense. But let's talk about how we store this data. So a field, or it is also called a column, right? So we're looking across. That's going to be maybe a name, a phone number, anything that describes one aspect of an object. You know, an object could be a customer, could be a product, whatever thing you're describing and storing data of. So actually, I'm sorry. So the column goes up and down, right? So it's going to be every name, every phone number, every email address. A row is horizontal, and that is a collection of fields about one object, right? So that's going to be one person's name, phone number, and email address. That's your row for that individual. A table is just a collection of those records, of those rows. And a database is a collection of those tables. So let's just think through the scenario that I'm going to use a little bit later on here when we get hands-on. I'm a video game type of person. So when you're playing Madden, you're playing a football game, right? There's going to be a table that holds information about the players, right? So you're going to have a players table. In that players table, you're going to have columns of the player's name, their jersey number, and maybe what team they play for. And then you're going to have another table of the player's statistics, right? So in the statistics table, you're going to have fields like how fast do they run, how high can they jump, how old are they, all of those sorts of things. When you take the players table and the statistics table, when you have that collection, that starts to become a database about all of your players. All right, a little bit more terminology bingo here. Right, database is a collection of tables. We got that one from the last slide. An instance is a copy of the database running in memory. That's a bit esoteric. Don't get caught up on that too much. More important is knowing DBMS is the database management system. That's the software that allows you to make a database and use the database. In this class, the DBMS that we're using is Microsoft Access. And then the database administrator, professionally, that's me. For the next couple weeks, that's all of you, right? That's the person who creates, installs, configures, and manages the database. So if this stuff over the next couple weeks starts to become interesting for you, that is a career path all to itself, and it does pay pretty well. Keeping going with the terminology here. Table, right? That's where you store your data. We talked about these ones. A query is how you search that database to find specific answers. That's a select query or your join query. You can also use a query to update the data, to insert a new row or update something that's already there. A form is a way to input the data cleanly and making sure that it's all in the correct format and no fields are missing. A report is how you analyze or present the data. And then the primary key is a unique number or some kind of code to identify a single record. So thinking about here at the college, you have your student ID number. That is your primary key in the college database. That's how they know what classes you are registered in, if you paid your tuition, what your grades are. All of those different tables have the primary key of your student ID to find the records about you. All right. The future of databases. Do we have any old head basketball people in here that know who that is on the left side here doing the disrespectful step over?
Iverson.
That is Iverson, right? AI. Now, when I say AI here, uh-oh, we got an echo. All right, we're good. So when I say AI here, we mean artificial intelligence, right? So that is taking your big data and it does all of the scary stuff, but that's also useful stuff. And that's even your self-driving cars and your Siri, all of those sorts of things have databases and big data behind them. I know everybody has election fatigue right now, but we do have a really interesting discussion on big data stuff and how that affected the 2016 election out here on Canvas. Just want to talk about it for a minute. This is if you only do one extra credit for the entire semester, I really suggest that you do this one just because it is, for me, really thought provoking. And this is one that kind of last semester came out of a discussion that we were having in class. And I went, you know what? This is something for us to talk about. So here in Canvas, today we're working on Module 9. Under Module 10, we have this extra credit big data discussion. And this one links you out to an article. And it's all about the data that turned the world upside down. And this is how, in the 2016 campaign, they were able to go in and do data mining on Facebook, right? So look at what people were doing, what pages you liked, all of those sorts of things. And this is what sparked our conversation in class, is just by looking at 68 different things that you liked on Facebook with 95% accuracy, the AI here, the artificial intelligence, could predict your skin color, 88% accuracy, sexual orientation, and 85% if you are more aligned with the Democratic or Republican Party. Think about how useful that is to somebody trying to target you with the right content and shape your opinion on things. So maybe a little bit scary there. We can go off the rails on it, but I really recommend reading through this article and just having a discussion about this. And there are a couple documentaries now about this same stuff if it's interesting to you and you kind of want to dive deeper into it. But the article is free for anybody to read. The documentaries are sometimes not so free. So I went there. All right. So let's go ahead. We're going to do hands-on stuff, but let's take a little break. We're at 1 o'clock now. Start back up at 1:15 for a hands-on demo with Microsoft Access. So I'll go ahead and pause the recording now, and we'll be back in 15 minutes to get started on the hands-on for today. All right, we're going to get into hands-on with Access now. But first thing, let's just do one of these quick little GCF videos to get a little bit familiar with Access. And then I'll work through a hands-on, and feel free to follow along with me if you can.
Foundation, creating opportunities for a better life.
Tables are the heart of any database because they are where the actual information is stored. And we're going to talk about how to add, edit, and delete information from a table. In the navigation pane, double-click on the table that you'd like to open. And tables will be marked with a blue icon next to the name. If you've used Excel or another spreadsheet program, then you'll probably find tables to be pretty easy to use, and they are very similar, but there are some different terms that we use when talking about an Access table. Each row is called a record. In this table, every record contains a customer's name, address, and other information. Each record will have a unique ID number, and this number cannot be changed. So Jared Smith's number will always be 3 no matter what. Each column is called a field, and each field contains a different type of information. For example, here we have fields for the street address, city, state, and zip code. Just like in Excel, each box is called a cell. If you want to change the information in a cell, all you have to do is select it and then type in the new text. And let's say that this customer has a new email address. After you edit a record, you can save it by clicking Save on the Home tab. But whenever you click out of a cell, it's going to automatically save it for you. So if you're making a lot of different changes, you don't have to worry about saving each record. But it is a good idea to save the last one that you're working on, just to make sure that you don't lose any changes when you close the database. If you are editing more than one record, you can use the arrow keys on your keyboard to move between records. Or if you prefer, you can use the arrows on the record navigation bar. You can also use the record navigation bar to create a new record, and then type in the person's information. If you want to delete a record, click the margin on the left side of the record, and then on the Home tab, click the Delete command. Now, normally you should avoid deleting records because it can negatively impact the database if other objects refer to the record. For example, if we deleted a customer's record, it could cause the information in the orders table to be incomplete. But if you're just deleting a brand new record, then it's generally okay. For some edits, you may want to use the Find and Replace option to make a lot of changes at once. I'm going to open up the Products table, and on the Home tab, click the Replace command. And let's say that in some of our seasonal products, we want to change the word fall to autumn. Type in the word that you're looking for and the word that you want it replaced with. And we'll select Current Document, so it'll search throughout the entire table. And we want to look for matches that appear in any part of the field. Click Find Next to look for the word. And it looks like the first instance of fall isn't referring to the season, so we'll skip this one and find the next one. When you get to one that you want to change, click Replace. And just go through each one and decide whether you want to replace it. And generally, you don't want to use Replace All because that doesn't give you the option of skipping any of them. So you should only use this option if you're absolutely sure that it won't replace anything that you don't want. As you practice editing tables, keep in mind that most of your changes are saved automatically. So to be safe, you may want to create new records to practice with.
All right, so you'll notice Access looks very similar to the rest of our Microsoft products that we have been working with. So now let's go ahead and I'm going to open up Microsoft Access on my computer, and we're going to build a new blank database together. Now you'll see I have a whole bunch that I've been working with, but what we want to do is right here, click on New Blank Database, and that's going to open up this screen right here. And on this screen, you can see that it automatically brings us into table number 1, and it has an ID column, and we have all of our familiar stuff on the top. Now, the example that I'm going to work through is a database for Madden ratings, right? So the first table we need is going to be the player info. So right now it's called table 1. I want to change that to be the name of my table, right? So I'm going to right click on this and then say save. And now it's going to ask me, what do you want the table name to be? And I'm going to call this player info. And now notice I did that same thing where I have no spaces and I did a little bit of capitalization on there just so it's easy to read. I'll say okay. And now it changed that to say player info. And we have our ID field, and any other fields we want to add, we can add across the top. Now, ID is fine here, but just to make it a little bit more clear, so right here on ID, I'm gonna right click again and say rename field. And instead of just ID, I want that to be player ID. So that way I know exactly what it is. Now let's add some columns, right? What do we need to know about them? We need to know their name, right? So now the first thing we want to do is the first name. When I come here and say click to add, it says, essentially this question is, what kind of data is it? What is the data type? So if we're dealing with just the first name, which one should we pick here? I'm thinking probably short text is going to work. Exactly. See it in the chat box. Thank you. So we get the short text, and then it says field 1 all on its own. We don't want that to stay field 1. Instead, I'm going to say F name, right? F for first name. And now I need another one for the last name. Short text again, L name. And then we want to say maybe what team do they play for, right? So team name. And then what position do they play? Right, so position. And now what's interesting here is that, so let's take a look at when we're in these fields. this stuff up top here changes. So if you chose the wrong data type, you can come here and change it to a different one. But we're going to stick with short text. And then over here on the field size, that says what's the maximum number of characters. Now in football terms, we have abbreviations for all of the positions, right? So QB for quarterback, RB for running back, WR for wide receiver. Those are all 2 characters long. So for position, I'm going to change that field size to be 2. So that way it will do a little bit of validation here, where it's only going to accept something that is 2 characters long. If I try to type in quarterback, it's going to say, no, you can't do that. It will only take QB. And then the last one that I want to hear is the jersey number. And in this case, because it's a number, let's use the right data type. Instead of short text, let's go with number on this one. And we will call this jersey number. There we go. Awesome, awesome, awesome. So now we have our player info table, and we have all of our fields or columns defined. Now let's start putting some data into them. In the chat box, if you have some favorite football players, please throw them in for me, and we will use them as examples. I was born in Dallas, having a bit of a rough year right now, but I do still love my Cowboys. So first one I'm going to use here is Dak Prescott, right? Dak Prescott plays for my Cowboys, and when his leg is not broken in half, he plays quarterback, and his jersey number is 4. All right. Juju Smith. I know he plays for the Steelers. He's a wide receiver. And what's his number? We'll leave that 0 for now. We'll come back to it. All right. Next we got Zeke Elliott. I see you have another man of culture here in class. I appreciate that. He plays for the Cowboys, and he is oh, look at that. I tried to type in running back, and it stops me. So it will only take 2, running back. And we know the best running back in the league is number 21. All right, Juju Smith is number 19. Look how easy it is to kind of hop around and fill in the information that we want. All right, Keenan Allen is on the Chargers. Another wide receiver, number 13. All right. Aaron Jones on the Packers is a running back who ruined my life in fantasy football when he put up like 40 points a couple weeks ago. And that is number 33, his jersey number. And let's do one more. All right, how about let's do somebody local, right? Let's go with Kyler Murray. he plays for the Cardinals. And by the way, with the Cowboys being so terrible this year, I have decided to hop on the Cardinals bandwagon. I hope nobody minds. So, Kyler Murray is a quarterback, and he is number 1. Oh, so when I type in this number field, look at that. When I try to type in something that is not just a numeric value, Access complains very loudly, right? It says, this is not the right data type. And then it gives you options, right? Do I want to change what I typed in? Or do I want to change the data type to accept it? In this case, I just made a mistake typing. So I'm going to change what I entered to just be the number 1 without the number symbol. And now everything is okay. So I think that kind of shows a little bit. In Excel, it wouldn't have caught that, right? It would let me enter that in, and then down the line, it would cause me trouble. In Access, you define the data type, and it says, hold on, wait a minute, you're doing something wrong. Or in a short text example, you can set the size so that it will only take 2, because when I tried to type running back, it doesn't let me put in any more than 2 characters. So that's a couple ways to have that data integrity. So this is the table view. I'm down here in the bottom right corner now. We can also switch to the design view by clicking this one right here. And now what the design view is, this is showing us all that metadata stuff, right? So it's telling us what are the field names and what data types do they have, right? So here for position is the field name, the data type is short text, and down here, the field size is 2. Now these are all editable, so I can change that field size to be 20, or I can leave it right where it is. Now, where it says required, yes or no. So right now, I didn't make any of these a required field. If you don't know it, just leave it and come back to it later. But you can instead say yes, and if you do that, it won't let you finish filling out that row and move on to the next one before you put a number in or whatever data it's looking for. And then one other thing here is using the jersey number. You'll notice that the numbers, when it was Juju Smith, right? I didn't know his number. It automatically put the number 0 there until I came back and fixed it. That's because it has a default value here of 0. So if you don't enter something, it will put a default value of 0. You may have heard on the news reports of dead people voting because the person was born in 1900 and there's no way that there's somebody who is 120 years old that went out and voted this week. Guess what? At some point in time, the voter registration was done in physical books, right? That got converted over into a database. What do you do when you're making that new database if the person's birthday can't be read, right? So maybe you can see that it's 19 something, but the last 2 digits got smudged. Obviously, you can't put somebody in without a birth year because that's going to be a problem. But you need to have some default value until you're able to go back and fix it. And in a lot of cases, a very common thing to do with databases is when you don't know the birthday for a person, to have that default value be January 1st, 1900, right? So if you are that way, when somebody comes back to look at it, they're going to know, actually, January 1st, 1900, we did that to meet the validation rules. But logically, we know that that's not the person's actual birthday. That's a default value. That's a placeholder until we come back and fix it. But somebody who doesn't have that perspective of working with databases is going to say, whoa, whoa, whoa. How did this person who's 120 years old end up voting? And then conspiracy theories abound. Little sidebar there, but as we start to learn these things and work with the software, it can actually just help you be more aware in life and in general. Now, one other thing is you'll notice on player ID, it has this little key next to it. That is because the player ID is the primary key on this player table. And the data type here is auto number. And what that means is that it automatically increments that number as you enter a new one, right? I didn't enter any of these player IDs. They just came 100% on their own. So there you go. That's how you create your first table in Access. And if you want to create a second table, right here on top on the ribbon, you click on Create and then click on Table. And that's going to create a new blank table. And this one, right, we have the player info. And one of the things we had here was the team name, right? Maybe table 2 would be about the teams. So when I save this one, I'll call it teams. And what kinds of things will be put in the teams? This is going to be the city, the state, and the stadium name, right? Just things that we know. And then let's think about how would we link these two tables together? Well, that's pretty easy, right? Because each player plays on a team. So one player plays on one team. That's a one-to-one relationship. Relationships, we have a whole, we'll get into that later, but let's just talk through it for a minute. Let's start thinking about that. And then one team is going to have many players. So that is a one-to-many relationship the other way. Don't get caught up on that detail. For this week, the only thing we need to think about is when you're creating your database and your two tables, which column are you going to use to link those two tables together? Which column is going to be the relation? Don't worry about what type of relation it is. Just make sure that you have a way to link the two of them together. You don't actually have to do that in this week's assignment, but make sure that you can tell me how they link together when we go ahead and do that. So let's flip back and look at our assignments for this week. So we're here in Module 9. right? So virtual classroom, all the database stuff. These first few pages are to review what we talked about in the first half of class in the PowerPoint. And we have a database basics quiz. So you know how these quizzes work. Good job last week. I'll go ahead and do the grading on the rest of those. But again, right, graded quiz in here on Canvas. You get 2 tries. It'll keep the highest score. I believe in you. And it tells you that it's all about the database 101 stuff. So the quiz comes from the stuff we talked about on PowerPoint. And the second assignment this week is hands-on in Microsoft Access. So we just walked through making a table together. The assignment for you is to create 2 tables. And then specifically, each table needs to have a primary key. If that default one works for you, great, leave it. And then I want to have 5 fields, right? So first name, last name, team name, position, jersey number, 5 fields. And then I want to have 10 records. So we only have 6 records here. For your assignment, I need this to go all the way to 10 rows, working your way down. Make sure you have the right data type, right? We had them as text or number or dates, whatever kind of data you're storing, choose that right data type. And then when you're doing your submission on Canvas, tell me what your primary key and why you chose that one. If you just kept the default, that's okay, but tell me why. And then remember that the 2 tables need to have 1 field in common, right? So in my example, the team name field is in the players table. And also over here in the teams table would be one called team name, right? So that same field is in both tables, and that's what we will use to link them together later on. So this one is kind of open-ended. The topic, what kind of data you're storing, can be whatever you want it to be, right? And now keep in mind, we're going to be kind of building on this for the next couple weeks. So have it be something that you somewhat enjoy working with. If you want to use that same example that I'm using of a kind of Madden or video game ratings player information kind of table, that's fine. If you want to use Pokemon, that's fine. If you have some kind of business that you are doing or volunteer work, right? This is whatever you want it to be. Keep it simple. Think of something that's going to meet the requirements. If you need some ideas, poke around here. If you just don't have any ideas at all, right? Pokemon, or expand on what we did together, or shoot me a message and I'll help you find something. But yeah, so that's it. Pretty open-ended on what exactly you do. I'm just worried about you working through the mechanics. And then again, as always, the specifics that I'm grading for are down here, right? So you need to have 2 tables, each one with 5 fields, 10 records in each table. So that's 20 records total. And then 1 field in common between those tables. In your Canvas comments, in that submission field, tell me what primary key and explain why you have that primary key on each table. So we have our quiz on the theory of databases, and we have our first access hands-on make two tables database assignment for this week. I'm going to go ahead and stop the recording now. If you are here with me live, now is the time for questions. If you're watching this later, thank you very much.